All right, so we'll be continuing with question 2 of section 1 from 2019. It says, express f of x equals minus 2x squared minus 7x minus 6 in the form a, open bracket, x plus h all squared plus k. Now, whenever we're given an expression like this, and we're told to express it in the form a, x plus h all squared plus k, it basically means that we're supposed to complete the square. So let's proceed. So we have f of x is equal to minus 2x squared minus 7x minus 6. Now, in order to complete the square of a quadratic, a must be equal to 1. In this case, a is not equal to 1. A is equal to minus 2. So the first thing that we must do is to factor out negative 2. So we're going to say that f of x equals, we factor out minus 2, and I'll factor out minus 2 from the first two terms. And so this will give me x squared plus 7 over 2 times x. I will leave some space inside and I'll put minus 6 outside there, right? Now, in order to complete the square of this quadratic, I must add a half of b squared. Now, inside the square brackets, of course, we have ax squared plus bx. And in this case, a is equal to 1, so we can proceed to completing the square. Now, b is equal to 7 over 2, and the half of 7 over 2 is, of course, 7 over 4. So I will add 7 over 4 squared, but I must also subtract 7 over 4 squared to ensure the expression does not change. And so what I end up with is this. F of x equals minus 2, close bracket. Now, this first three terms is going to give me what is called my perfect square, the first three terms. And so I will get x plus 7 over 4 all squared inside the square bracket there, right? And of course, outside I have my minus 7 squared, which is 49 over 16. And of course, I still have my minus 6 outside. So let's proceed and continue over here. And so what I have so far is f of x is equal to minus 2 bracket x plus 7 over 4 all squared minus 49 over 16 close bracket minus 6. So we expand the brackets and try to simplify. And so we get that f of x equals minus 2 bracket x plus 7 over 4 squared. Now, inside, we're going to multiply the minus 49 over 16 by the minus 2 outside. And that essentially will give us, what's that? 49 over 8, or we could say 98 over 16, which simplifies to give 49 over 8. And that's going to become positive. So we have plus 49 over 8 minus 6. All right? And so we see that f of x equals minus 2 bracket x plus 7 over 4 squared plus 49 over 8. For the purpose of combining these, I could write 6 as 48 over 8. And so what I have is f of x equals 2 bracket x plus 7 over 4 squared plus 1 over 8. All right? And I've therefore managed to complete the square of this quadratic, which means that I have expressed it in the form f of x is equal to a, open bracket, x plus h all squared plus k. All right? So I've managed to do that. Now, what's the next part of the question? The next part of the question says, state the maximum value of f of x. Now, if you look, oh, sorry, this is supposed to be a minus 2. I forgot the minus sign right here. So this is equal to minus 2. Now, whenever we complete the square of the quadratic, then the value outside here, which of course is k, is always going to be the y-coordinate of the turning point, right? So the y-coordinate of the turning point is this value out here by itself. Now, whether or not is a maximum or a minimum simply depends on the value of a for the particular quadratic. In this particular case, a is equal to minus 2, which obviously is negative, and this means that the quadratic will actually be a um, will shape like that. And so therefore it will have a maximum point. Okay? And so therefore the maximum value of f of x is of course the y coordinate at the turning point, which of course is 1 over 8. Alright? So the maximum value of f of x is equal to 1 over 8. And they also ask us to state the value of x for which f of x is a maximum. To state that value, we look at the brackets, the expression inside the brackets, x plus 7 over 4. And the value of x for which this is equal to 0 will be the x coordinate at the turning point. And so this value is of course x equals minus 7 over 4. So essentially what we have here is our turning point. And this basically means that the maximum point is minus 7 over 4, 1 over 8. All right? So that was part 3. Now let's look at part 4. Part 4 says use your answer in A part 1 to determine all values of x when f of x equals 0. So in A part 1, we were required to complete the square, which of course we did. And so we can basically write that f of x, let's just write it down here, f of x equals minus 2 bracket x plus 7 over 4 all squared plus 1 over 8. Now, we want to solve f of x equals 0, and so, of course, we must equate this to 0. And so we have minus 2 bracket x plus 7 over 4 all squared plus 1 over 8 equals 0. And let's continue over here, right? So we now can bring the 1 over 8 to the other side, and we can say that minus 2 bracket x plus 7 over 4 squared equals minus 1 over 8. And so the two minus signs will cancel. And of course, we can divide both sides by 2. Or essentially, we say we divide both sides by minus 2. And we get x plus 7 over 4 all squared is equal to 1 over 16. The next step is to find the square root of both sides. And of course, when we do that, we get x plus 7 over 4 is equal to plus or minus the square root of 1 over 16. And so we get x plus 7 over 4 is equal to plus or minus 1 over 4. And let's solve for the values of x. So when the square root is plus 1 over 4, we can say that, let me change the color here. We say x plus 7 over 4 equals 1 over 4, which means that x is equal to 1 over 4 minus 7 over 4. X equals minus 6 over 4, which is equal to minus 3 over 2. All right? And then when the square root is actually negative 1 over 4, we can say that x plus 7 over 4 is equal to minus 1 over 4, which therefore implies that x is equal to minus 1 over 4 minus 7 over 4. X is equal to negative 8 over 4, which of course is equal to negative 2. And so therefore, these are the roots of our quadratic. X equals negative 3 over 2 and x equals negative 2. Now it says sketch the function f of x and show your solution set to A4 when f of x is less than 0. So we know for a fact that the graph is going to shape, is going to be a maximum because a is negative. And of course, we can determine the y-intercept as well as what else do we need? We know the turning point already. We've determined that. The turning point, of course, is the point minus 7 over 4, 1, 8. We know the roots, we know the nature, and of course, we know the y-intercept because the y-intercept is essentially f of 0, right? So in this particular case, f of 0 equals minus 6 from the equation that we're given. So it's a rough sketch for 2 marks. So we can basically do a quick little thing. Let's see how we're going to go about the sketch. So, nothing too sophisticated. Something like this. Turning point, something like this, turning line, something like this. And it comes down here to have a y-intercept, right? Something like this, y-intercept somewhere down here, right? Yes, something like that. And so this value right here, so these values are our turning points. This one would be minus 2. This is minus 3 over 2. And here we have in between, directly between the turning points, sorry, directly between the roots, we have the turning point, which shows our axis of symmetry, right? Let me fix it up a little bit, right? So if we were to draw that line right here, then this point would be um, minus 7 over 4, right? That's minus 7 over 4. And of course, as it did mention, that the y-intercept would be equal to negative 6. So it's a rough sketch, nothing too fancy, but that is essentially what the rough sketch looks like. The sketch looks like. So let me just fix it up a little bit, right? A little bit. So the turning point right here, I find the color. The turning point right here, that point would be minus 7 over 4. So minus 7 over 4, 1 over 8. So that's the turning point. And so what have we managed to show on this sketch? We have the roots, x equals minus 2, x equals minus 3 over 2. We have the y-intercept at y equals minus 6, and we have the turning point at minus 7 over 4, 1 over 8. Now, the next part of the question basically asks us to solve the inequality when f of x, or to show the region to the inequality, solution to the inequality, f of x is less than 0. So we see the graph of y equals f of x. So for f of x less than 0, we're talking about, where is that region now? Less than 0, less than 0. Oh, we're talking about over here, right? Here. Because clearly, between minus 2 and 3 over 2, the graph is on or above the x-axis. However, to the left of minus 2, it is below the x-axis, and to the right of minus 3 over 2, it is below the x-axis once again. So these shaded regions will be the solution to the inequality f of x is less than 0. Okay? Yes, that is that. All right, so let's move on to the next part of the question, which deals with geometric series, or we commonly refer to as geometric progressions. So this part of the question says a geometric series can be represented by y over x plus y squared over x cubed plus y cubed over 5. Prove that the sum to infinity, that is what that means, s infinity, equals xy times x squared minus y to the power of negative 1. Now, first of all, before we can proceed to find the sum to infinity, we have to find the common ratio of this geometric series. Now, if you recall, a geometric series is, or progression is one in which the ratio of consecutive terms is a constant. Now, in this particular case, we have our first term, that is t1, equals y over x. We have t2 equals y squared over x cubed. And so we have t3 is equal to y cubed over x to the 5. Now let's check the ratio of t2, t1. Then this gives us y squared over x cubed divided by y over x. The same thing as y squared over x cubed times x over y. And so when we do that, we get, that's going to give us y over x squared, right? So let's check the others. Now let's also check t3 over t2. So t3 over t2 would be equal to y cubed over x to the 5 divided by divided by y squared over x cubed. And so this gives us y cubed over x to the 5 times x cubed over y squared. And once again, this is going to give us y over x squared. So the mere fact that the ratio T2 over T1 and T3 over T2 gives us the same value. Obviously, this suggests that the terms are in geometric progression, and of course, they form a geometric series. And so basically what we know is that the common ratio R is equal to y over x squared. Now, for the sum to infinity of this geometric series to exist, it basically means that the series must converge. And the condition for the series to converge is that minus 1 must be less than the common ratio r, which must be less than 1. So whatever value y is, whatever value x is, the ratio y over x squared, or the fraction y over x squared, must lie between minus 1 and 1 in order for the sum to infinity to exist, right? So with that in mind, we can now say that the sum to infinity, S infinity, equals the first term A divided by 1 minus R. And that's typically how we find the sum to infinity. And so the sum to infinity is equal to A over 1 minus R, where A is the first term. And this, of course, is y over x. So it's y over x divided by 1 minus y over x squared. And we'll try to simplify this. So we have y over x divided by, this is the same thing as x squared over x squared minus y over x squared. And let's change the color and go across, right? So I could make some space over here. All right, so the sum to infinity, S infinity, is equal to y over x divided by x squared over x squared minus y over x squared. And so this gives us y over x divided by x squared minus y over x squared. And of course, whenever we divide fractions, we invert or flip the second fraction, change the sign to a multiplication, and this gives us y over x times x squared over x squared minus y. Now these two x's will simplify. We say x into itself goes 1, x into x squared goes x, and so this gives us, let me see now. So we have yx, same thing as xy, divided by x squared minus y, which of course they chose to write like this, xy times x squared minus y to the power of negative 1. And this, of course, means that we've actually shown our result, that the sum to infinity is given by that expression. All right? And so this is the end of this question, question 2 from section 1 from paper 2 of 2019.